So the football players are going to read the kids' assignments. At 9, I put down there at the post office.
Okay. Quiet, please. So some of the stuff we've talked about, we're just kind of like going through it again and formalizing it and putting it in the notes. So hopefully some of it looks familiar. Then we get into residuals, which we haven't really talked about yet. Let's fill out these. So if we think that a variable may explain the changes to another variable, we call x and. The word explain. What kind of variable is x? Explanatory, because we think it helps explain what's going on with the y value. You could also say it's independent. And then y is a response variable because it's responding to the x. Like the cost of the pizza responds to how many toppings you want. So the number of toppings explains the cost of the pizza. This is a scatter plot. It's just like the definition of a scatter plot. And then when I ask you to describe a scatter plot, what are these three blanks that we practice looking for? What is it? What does FDS stand for? Form, direction, strength. And then sometimes, like I think Khan will ask you to find outliers. Sometimes they do and sometimes they don't. Read through the example and see what you think is correct there. 20% of the points are highly correlation. Don't put that one. I don't even know what that means. So A is not it. That's not even like a sentence. Perfect correlation would be R equals what? Or -1. So it's not B. This one is the one that's true. So if I have a relationship between like how much I study and how well I do on the test, it doesn't matter if I say like test versus study, study versus test. That relationship exists. There is a relationship between studying and your grade of test. And it doesn't matter if I switch it. It doesn't matter if I measure your time in hours, minutes, days, your grade in percent, standard deviations, whatever. I can do whatever I want, and the correlation will not change. D is false because extreme values would affect it. Remember, if I have a bunch of dots like this and I put a value like up there, that's going to weaken my relationship. And then this is not how correlation works. Least squared regression line. So in the notes, they go through like how to do it by hand, but we're not going to do that because we have the calculator. So we're going to skip over a bunch of this. But the line of best fit is also called the linear regression line, or like yesterday, some of you guys were like, what is a regression line? It's just the line of best fit. It could also be called least squares regression line. Those are all the same thing. We're just trying to find like a linear pattern to the data. So the formula is going to be either we do this, but it could also be this. Wait, no. We do AX plus B, didn't we? It could be either one. I just got confused which one I showed you guys. I think your calculator offers you both of these options. Doesn't really matter which one you use. You just gotta know that the number in front of the slope is, or the number in front of the x is the slope. So if you use this method, slope is A, y-intercept is B. If you use this method, slope is B, y-intercept is A. I'm going to try to default to this one. So in that case, your predicted y value would be y hat. Don't forget the hat. That's what makes it predicted. What's the explanatory variable? X. Slope. A. Y-intercept is B. And then remember, include context. So like x equals whatever and y equals whatever. Am I good? Alright, turn page. So I'm going to show you in the, here there's a little, it's called the least squares regression line. I'm going to show you what the least squares part is trying to get at. Okay. So this is just a site that has a bunch of just data on there. I can kind of pick whatever I want and look at a scatter plot of it. So it's automatically giving me the best fit line. It's telling me my correlation coefficient. That makes sense, right? It's like really strong, but not perfect, so it's going to be a high positive number. So the residuals are going to be the vertical distance between each point in the line. So like if I look at this person here, what I expected would be way down here. The actual value was way up here. This distance between these two is the residual. It's like the leftover, the extra. So I can show that, like those vertical lines are the residuals. If I add all of those up, so positive is above the line, negative is below, what do you think I'll get? Louder. It's 0. So there's like a huge positive one up here that really, but if you add up all these positive ones up here above the line, and then all the negative ones below the line, they would be the same. So you would get 0. And then squared residuals, so it's called the least squares regression line. And this is what's actually happening. Your calculator is going through and saying, all right, if we squared all of those distances, so I took this distance from here to the line, squared it, so I'm like making it an actual square. I want to make the areas of those squares combined as small as possible. I'm trying to minimize the area. So think about if I put a point like way over here, you're going to have like a giant area. And then your line would have to bend toward that to make that area like a little smaller, but not make other points bigger. So you don't have to do it by hand. Your calculator's just doing it. But you will get questions about that we're trying to make the sum of the squares as small as possible. We have talked about slope and y-intercept, and we've done it better than this sheet does. I want you to plug those into your L1 and L2. But this is like going through it by hand. We're not going to do that part. We're going to put them in, then we're going to jump to step 4. Remember, if you move your cursor up to like where it says L1 and you hit clear and then enter, it'll clear all the values up for you. If you hit delete and then enter, it destroys it. And then we gotta like reset things. So hit clear, not delete. equation. Okay? So then I want to jump to step 4, because the rest of it's going through how to do it by hand, and we're not doing that. Use your equation to predict what evaluation Mrs. H would get from a student who scored an 81. So that's their grade, so that's their x value. So we want to find the predicted value. So y hat is 1.34 times their grade, which was 81, minus 29.3. I get 79.24. I could do it backwards too. I could say like if the predicted evaluation was 90, say what score we think we got. So I could have you plug in for y hat or x, either way. Interpret the slope. So this causes a lot of issues, like almost every year. It really helps to slow down and like go through step by step what's happening. So slope is change in y over change in x. Well, in this problem, that's the change in the evaluation divided by the change in the grade. And then our slope is what? 1.34. And we want that to be a fraction, so I just throw 1 on the bottom. And then it's always going to be as, like the x value, but I'm just going to put grade here. It's always the x value. Increases by 1. What's the next couple words? We expect. In this case, it'll be eval, but it's just y every time. To increase or decrease? Increase, because that's positive number. So as the x value increases by 1, that's the x. So that's what I'm trying to show with this like setup, is the x value is 1 and the y value. Part D, do we think student grades and evaluations are related? Why or why not? Or explain. Do we? Why? How do you know that? Prove it. Prove it. Convince me.
Take my test.
So my evaluation. Pena. Prove that to me. I don't know. How'd you get that? Claire. You're right. You just gotta prove it. What about R? I don't know. I'm asking you. Don't ask me. What's the R value? Point what? 904. So yeah, that's what they're looking for. So you're right. Like, what did you say? I forgot. Correlation is strong. So you just gotta like prove it. So R is 0.904. So high correlation means they're. I would even say strongly related, because that's pretty high number. So you can't just go about, yeah, like it makes sense, right? That if you are failing the class, you're not going to blame yourself. It couldn't be your fault. It's the teacher's fault. They suck. I'm going to give them a crappy evaluation. But so that's just like logic. You can't really use logic. You got to prove it with data, with numbers. Could we say? Could we say that student grades cause teacher evaluations? No. We cannot. Correlation does not equal causation. Like, is there another variable you could think of that would make both of those things high? Like, maybe school is just really important to you. So you do well, and then you give your teachers high marks because, like, you respect your teachers. And that has nothing to do with your grade. Like, it has to do with your grade, but there's something else in the background that's like impacting both of them. So you cannot say, so correlation does not equal causation. I think we've written this down a couple times. I'm going to do it again. Correlation does not equal causation. It might, but you can't say it for sure. There's a good example of it at the bottom of the page. It took me a minute to figure out what's going on there. So there's a strong positive linear relationship between ice cream sales and homicides in New York City. So this one's better though, I think, because it took me a minute to figure out what the actual cause was. What? I don't know. Oh, it's not like a horror movie. This is a real person then? Okay. That's not what's going on this problem. So, ice creams are causing homicides?
No.
Yes?
No.
It'd
Yes?
be hilarious if it was.
Ice creams are causing homicides. Do we think so?
Yes.
You think so?
People are killing people with ice cream, apparently.
People are murdering people with ice cream.
Lactose.
So, what's
No.
what's going on there? Why are they positive? They are. There is a strong positive linear relationship. In what?
People are getting murdered in ice cream shops.
People eat ice cream, they're lactose intolerant, so they get angry and start shooting. William. So this is all in 1 year. Yeah, I mean, I don't know if the example said it that well, but we can. So this is in 2023. On day 1, there were 2 ice cream sales and 2 murders. On day 100, there were 100 ice cream sales and 100 murders. After murdering someone? Oh, so the murders cause people to buy ice cream.
Ice cream that has people like it.
Maybe more murders happen in the summertime.
That's what it is. That's what it took me a little while to think about it. So there's actually way less homicides in the winter because I guess murderers don't like cold weather. You want it to be a nice day for you.
I was gonna say people gather in groups for when they got ice cream, you got groups. Of people
Yeah, so that's
they
weather
want,
related
and that's
too, right?
That's an easy target.
You want to homicide less. It's correlated to temperature. Yeah.
I think we need a second graph.
I didn't.
I'm pissed. I don't care what.
Yeah, but if you're pissed and you gotta put on a winter coat and boots, well, that's not worth it anymore. Okay, coefficient of determination. So yesterday, or we have so far talked a lot about R. The coefficient of determination is R squared. It's not like yesterday I gave you R squared and I asked you to go back to R. So it's literally just squared. It's not like a different term or anything. It's literally just squared. So if I give you this and I ask for correlation, what would you do? Square root it. But be careful. Let's say, I never know what you mean. Let's say R squared equals 0.49. Okay? And I ask you for correlation. You should ask me another question so that you can know the answer. What else would you need to know? Don't say anything. Were you answer it? Just wait a second. So if you square root that, what's the square root of 49? That's 7. So if you square root this, R is going to be a form of 0.7. Do I know from this whether it's positive or negative?
No.
Because the square root of 49, I'm sorry, I stole your thunder. Is that what you're going to say? So the square roots are 7 and negative 7. So R would be positive or negative 0.7. So you would have to know, is the slope positive or negative? If the slope is positive, you would take the positive R. If the slope were negative, you would take the negative R. Very common question on the unit test, on the AP test. They'll give you this, and they'll tell you, y hat equals negative 0.2x plus 4, or something with a negative slope. And they'll give you R squared, and they'll ask you to find correlation, and you like feel proud of yourself because you're like, oh, I square rooted it, I got 0.7. Awesome. Let's go to the next one. And then you got it wrong because you didn't go back and realize it's a negative slope, so you should choose the negative. So you will be like, I will try to trap you, and the AP test will try to trap you with that. Yes. That's how right and wrong works.
I know, but
You mean like no partial?
yeah, no part.
Yeah. Because the whole point is like, just make it negative.
You just want to like
Okay. So R squared is like we're not going to get into it too much. You basically can memorize the definition, but I'm going to try to explain it. So our last example here, our R was 0.904. So let me go back to the last one and let's find R squared. 0.904 squared is 0.817.
wait, what's that?
Yeah, do you agree?
I got 0.95.
You square rooted it. Remember a second ago when you said like, you know what I mean? Do you know what you mean?
Gunner, when you look at the thing, it says 0.8175935 691.
What? But that's not the decimal I got. Is that what you guys got? What is your decimal? This is not like stats related. I'm just.
0.8175935 691.
You did 0.904 squared.
I got 0.817.
That's what you get.
And it gives you the R squared.
Oh, okay. Okay, so that's another way. So you can go. Yeah. So you just were looking at that, and then go. Okay. All right. So. But back to what this would mean. So the grade in the class almost fully predicts how the student will evaluate the teacher. It almost fully predicts it. It gets 81.7% of the way there. So there's a bunch of factors that go into the last problem. There's a bunch of factors that go into the evaluation of the teacher. If we just look at the student's grade, we have covered 81.7% of the factors. So there's like 18-19% left that we haven't there's more to explain, but if I just use this one variable, I can get 81.7% of the way there. So it's like 81% accurate is a kind of way to think about it. But the phrase that AP test will use is this proportion of variation that is explained. So in our last example, R was 0.904. R squared was 0.817. And so what that means is 81.7% of the variation in the data. So 81.7% of what's going on, of what I'm trying to predict. But they like this phrase in the variation of the data. Then realize, like up here I put proportion of variation, down here I put percent of variation. Those are the same thing, right? Proportion and percent are the same idea. Can be explained by our regression line. But if I stop there, what am I missing? Someone just said it. Context. So can be explained by our regression line on grades and eval. So you're putting the context, like labeling your graph, putting the context in. There's a different way to write it out down here. 81.8% of the variation in teacher evaluations can be explained by This would be like the regression line. And then class average. So they kind of put the context in the middle of the sentence where I put it at the end. It doesn't make a difference. You just want to put the context somewhere. Alright, question on R squared. Okay. Try to fill in the blanks in this. Maybe you can't. Never mind. We can do some of them. We use the line, so our regression line, our linear regression. We're trying to predict what from what? X from Y or Y from X? We're trying to predict Y. Y is the response. It's going to respond to whatever X is. So we think X predicts Y. And the errors we make are in the, so I put that graph up with like the lines to the line. Are the errors in the vertical direction or the horizontal direction? They're the vertical. It's the vertical distance from your dot to the line. A good regression makes the vertical deviations of the points from the line as small as possible. And then a residual. So this is a new word. So it kind of sucks is you got R and correlation. So I'm going to make a list of these in a second. You got R and correlation, which is the same thing, but correlation has two R's in it, so that's like confusing. And then you got R squared, and now you have residual. And they all kind of like sound the same, so it's very easy to confuse them. So residual is, so it's observed minus predicted, or it's Y minus Y hat. And it's the distance between point and line. So I'll show you a couple on the next page. Right now I know it's like conceptual and vague, but we've talked about this a little bit. If the residual is positive, the observed point is above or below the line. Positive would be above, and negative would be below. So if we turn the page, we have an example, but I don't want to turn it. So is everyone done writing? Okay. So a residual plot, or a residual is just the literal distance between that dot and what we'd expect that dot to be. So I can draw it on the board. I don't want to draw it. So this point's really hard to tell, it's really small, but it's like a little bit above the line. So it would have a very tiny positive residual. Positive residual there. This is below the line, so it would have a negative residual. Positive, 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 negative, negative. So you're just drawing like a vertical line to the line of best fit, and if you're above it, you have a positive residual. Below it, you have a negative. And then the point of the residual line is it takes these distances and makes them in as a whole as small as possible. What will these distances add up to if I add them all up at the end? 0. Okay, so find and interpret. Spell it here. Ford F-150 that had 70,538 miles and had that price. So is miles my X or Y value? Miles is X. Price is Y or Y hat? Price is Y. My job is to find Y hat. And then see what the difference is between them. There's a mistake on this graph, I just realized. Anybody else not bother anyone else, or anybody else notice it? The what? Yeah. I was going for no Y hat. And you don't know what you mean. What do you
suck much.
You're saying like you just wanted to keep going forever. Okay, so my residual is going to be y minus y hat. Some people think about that as actual minus predicted, and then it makes the word wrap. Just like a little thing to help people remember. So my residual is going to be the actual y value, which is what? 21,994 minus the predicted y value. Well, how do I find the predicted y value? I plug it into the equation. What do I plug into the equation? The x and the y. I plug in x, because we think x predicts things. So I'm going to plug in x and see what the price would have been predicted to be, see what the price actually is, and find the difference. So we're looking at 70,000 miles. I think it might be this point. But let's plug it in. So let's plug in the miles. So y hat equals negative 0.1629 times 70,583 plus 3825. Why can't they make the numbers just like 0.12? So many unnecessary decimals. So that point's not graphed. You guys get 26,759? Are you about to? So remember, this is your actual value. That's your predicted value. So I'm going to subtract those. So I get negative 4765. So is this truck costing more or less than we would expect it to? Less, because this is negative. So this point, it doesn't look like it's on the graph to me. 70,000, comma 26,000 would be like right here. So this negative 4765 means it's 4765 below that line. If you make a residual plot, which would mean you went through every single point, but just like, okay. So that point up here is like a tiny bit above what we'd expect, right? That is this point here on the residual. We start at 0 and we go, okay, that's a tiny bit above what we'd expect. Second point is like a little bit below the line, right? Second point is a little bit below the line. So you're literally graphing the distance, like that distance up there is the exact same as that distance down there. Just to pick out like a couple other points. So like this point here is this point here. So this would tell me, let's do that. This is, let's say, I don't have an x-axis here. That point on the original graph, is it above or below the line? Above, and I would have a positive or negative residual. Positive. This point here would be below the line with a negative residual. Okay. You're not going to have to make that residual graph, you just have to interpret it usually. So turn the page. So your residual plot will either look basically like random, so a bunch of scattered points. This means a linear pattern, our linear regression line, RLSRL, is appropriate. So a linear model works well. What we want to see is a bunch of random scattered, there's no pattern there. sometimes see and is bad, you'll get like a very clear curved pattern. So something like that. This would mean a linear pattern is not appropriate. So basically this would mean like I could have done a better job by using some kind of curve instead of a line because my data is curved. So that will come up in the homework. All right, let's go back a page. I just want to review a little bit. Take a second and either write down or think about, interpret the slope and interpret the y-intercepts for the previous example. Write down, think about it, whatever, but I just want to practice. Interpret the slope, interpret the y-intercepts. Well, I want you to practice. I'm pretty good. This one?
Yeah, where it's on the graph.
I'm just reading that.
Oh, that's a 6. Okay. I thought it was 0.119.
Oh, my writing.
Yeah.
Yeah, that was kind of a sloppy six. Alright, so the slope is this negative 0.1629 number, right? But I would make it negative 0.1629 over 1. And then that's delta y over delta x. Y is price. And x is miles. So to interpret the slope, I would say as the miles increase by 1, we would expect the price to decrease by, I guess, 16 cents, 0.169. So as the miles go up by 1, we'd expect the money to decrease by this amount. Is that part okay? Interpret the slope. For the y-intercepts, so remember it's like 0,38257. So this would be, if we drove 0 miles, we would expect the cost to be 38,257. That's not new, I'm just reviewing those two things. Questions on those two? Alright, I'm done. Start working on homework 3, but we're skipping a bunch, so like come with me, I'll tell you what to skip off. Skip off, cross off. On the first problem, A, B, C are all good. We're not going to worry about D, E, F. No, I think that's it. Number 2 on the next page. Cross off the word draw. What are we going to write there? Sketch. Are you going to interpret it too? But I don't want like a huge drawing. Just like boom, boom, put some dots. Don't make a big deal about it. And number C, or letter C on the next page. And the rest is good. Yeah. This one we'll do tomorrow in class together. Maybe go through those again? So, on the first page you're fine. On the second page you're skipping D, E, and F. On the third page, just change draw to sketch. I don't want you to spend 20 minutes making a beautiful scatter plot. And then on the last page, skip C. Sorry, not last page. On that page, skip C. And on the last page, I'm going to do number 3 together. We'll do class tomorrow. Alright, so go ahead and start working on notes or homework 3. Oh, they're not, are they? I will. Look at this one I told you to sketch also. Just before you accidentally head down the wrong path. We've got the temperature and we've got the latitude. They don't tell us which is which. So you gotta think through, does it make sense that like the temperature predicts where you are on the Earth? Or is it where you are on the Earth predicts the temperature? The second thing I said, right? So X is the latitude and Y is the temperature. So just make sure you get that. That'd suck if you grabbed all those points and did it like backwards. And yeah, I'll put the answers up right now. My bad.